Okay, so in the last video we were building this servo and gear unit for the top of the Bicep. Doesn't really look much like a Bicep at the moment, but hopefully we'll change that in this video. It was quite some time ago when I printed out all these parts for the Bicep, and I think I might be one or two bits missing. But I've taken a bit more of a detailed look on how this thing fits together. I think I've just about worked it out. So if we start with, sorry, I don't remember the names of these parts, but basically you get this upper and lower piece. I believe this is the upper piece of the Bicep and this is the lower piece. So they're obviously going to fit together. Must be that way around. So you do need two sets of these for each Bicep. We're just building one Bicep, so we need just a pair like I've got in front of us here. I've taken a look at these parts and they just appear to be the same parts are just repeated twice. So you don't need like left-hand versions and right-hand versions. And I believe the entire Bicep is the same for the left hand and the right hand. They're just identical, so you just duplicate your parts. However, I have noticed one issue I'm going to have is with this lower Bicep part, there is a location here for the potentiometer to go in. If you remember on the last video, we removed the potentiometer from inside the servo and we have to mount it in this hole here. Only the potentiometers that came with my servo are square, and this is designed for a round version, so that's not going to work. I can't see any alternative for this component on the InMoov website, but you can find them on Thingiverse where somebody has modified this to a square hole, so I'll need to download one of those and reprint this part. However, I'm not going to waste these parts because I believe even on the other side there is a location for a servo, even on the other side there's a location for a potentiometer, you just don't use it. So I'll be able to keep the round version on the side that's not going to have the potentiometer and just replace this one piece on the side that does, and then I can again reuse this on the other arm. So I haven't wasted the printing time or the material. So I'll have the two sides of the Bicep and then they have this spacer in between them. I believe we just need one of these. The top here will attach to the motor unit that we built last time. There must be another piece in between here which I'm missing. I need to find out. And then basically you have this servo gun, which is, I've heard described as a servo gun, which is these two parts here. I may have this on the wrong way round. A servo will go in there somehow, and then one of these threaded pistons, this is actually the wrong one, I believe this is probably from the shoulder mechanism, will attach to the top of the servo, and we'll end up with this kind of gun-shaped piece, which is the servo driving this threaded piston. That then will fit into this block here, which will be located up here in the top of the Bicep. I think you get the idea. That'll sit in there, and then the servo gun will be driving this piston into that, pulling this whole servo up and down, which I believe it's a bit hard to visualize it at this stage, but it will pivot on this point, and that's basically creating like the flexing mechanism. If you imagine yourself flexing your biceps, that's really what this unit is simulating, which will actually drive your elbow joint, or the robot's elbow joint. It's a little hard to visualize, but I think I've got it all clear in my head where most of the parts go and how we put them together. There are videos and tutorials online, so I'll have to look a little bit deeper into those, but these are basically the parts we need. I do need to replace this with the correct one, and we're clearly missing some component at the top which attaches this mechanism to this, so this will be providing some rotation in the bicep, whereas this one will be providing like the flexing mechanism which will give us the elbow joint. So this square block here with the thread in it has to fit into this round hole in the side pieces. It doesn't fit in there at the moment, so I'm going to give this a file out with a round file, and file a little bit around the top of this. It wants to be a nice snug fit, but still loose enough so that it can rotate freely. So it's fitting in there now, but it's still very tight, so I need to keep going a bit more on this. I've popped it in a vise. I'm actually finding it easier to file this part down and use some sandpaper around the outside of this part than it is to try and get a round file into that hole. It just seems easier to work on this part than it does on this. So I'll keep going a bit more, see if we can get it a bit looser. It is fitting on there now, so it's nice and flat now, but it's still too tight. We don't want to make the servos work too hard. So I've got a few things on the go here. I'm starting to build up the main frame of the bicep. I just need to print a new part for this so that we get one with a square hole in it instead of this one with a round hole. I've got that on the go on the printer. You can hear that in the background printing now. We've got our block in there now with the thread inside. That's nice and loose, it's moving freely. Just got this support bracket. I've primed this part, and I've primed one half of the frame. Just needs the colour coat putting on. I'm not sure if I'm doing it black or white. Haven't quite decided yet. Yeah, we've got the servo holster over here ready, and I've also printed off this little holder that just holds the gear in for the potentiometer. We've also got the gear here for the potentiometer, so they're ready to go. I'm missing one of these. These are support braces. I've only got one, so I need to print another one. And I've got the second modified servo. I need to extend these cables, so I'm going to do that next, so I can get a longer cable onto that. We should then be able to fit the servo into the servo holster. So mainly for my reference later, in case I forget, the way I'm going to connect these wires up is I'm going to connect the red to the red. That's fairly obvious. I'm going to connect the light coloured yellow to the light coloured white cable, and the dark black to the dark green. It's kind of the way I remember it. Red's obvious, and then we've got the light colours and the dark colours. Okay, so there we go. For reference later, we've got white to yellow, black to green, red to red. Okay. So then the servo just slides down inside there, and the cables come out of this little cable slot in the side here. I think that's what that's designed for, so to let your cables out. You can just see they come out of the servo there, up there and through that hole. So it looks like we're free to screw the servo in and screw this extra bracket on the bottom. So I'll do that. Okay, so that's screwed on. I just used M3 screws. They're machine screws. They should really be self-tapping screws. You can see here they're just a normal screw with a thread that you would normally fit a nut onto. But they grip into the soft plastic quite easily and they're the right size, so I just went with those. Seem to work okay. I didn't really need to drill the holes out. I did drill this top piece out to 3mm clearance holes just to clear the 3mm screws. Normally I would drill the threaded holes 2.5mm, but they already seem to be that size, so I didn't need to do anything with those. When I do the drilling, I do use these hand tools so we don't risk cracking any of the plastic with a power tool or anything. It's a little bit slower, but it's safer. So this is the part I downloaded from Thingiverse. It's exactly the same part as the original, but it's just got the square hole here instead of the round hole in the original. So this will take our potentiometer, which is square, not round. So I'll quickly show you this. Here's our potentiometer and the square hole to fit it in. There's no locating hole this time. We've got this little locating lug on the end of the potentiometer, but there's no hole in this part to fit it. So I did think about maybe drilling a small divot in there for the lug to fit into, and then I decided it's probably just easier to just file that little lug off the potentiometer and just get rid of it, because once that's in there, it's a square hole anyway, it's not going to rotate, so I think that's fine. As for which way round it goes, it's not actually a square hole, it's a rectangular hole, so it has to fit either this way with the wires pointing upwards or this way with them pointing downwards, but because the round hole is sort of off center, I think the only option is to have it with the wires pointing upwards. I've now got the whole frame assembled with the block in there with the thread and the spacer down in here. I've got the potentiometer in the back there and the gear on the front, and this part will actually be on the attached to the forearm, forming the elbow. I've run a M8 bolt through here. I haven't put a nut on the end. The bolt's a little short, but we might just get away with that. Something I'm finding a little strange here is the amount of movement we get in this. We only get a tiny amount of movement. So it goes kind of flat, and then it's only moving up about 45 degrees. So I'm uncertain if that's correct. It doesn't seem to be much movement. I thought we'd get about 90 degrees of movement, but that is hitting on this piece here, so it can't open up any further, and when we close it up it's hitting here, so that also can't move any further. So I'm a little baffled by that. That might be correct, but it doesn't seem like much movement. So the next stage will be to complete the servo gun. I need to print the threaded piston, which will attach on here like this. This isn't the correct one. I believe this is one from the shoulder joint. Doesn't seem to fit into this thread here. I think they're different. I thought I had this one, but it appears not, so I'll have to print one out. Okay, let's have a look at putting the whole assembly together. We've got the rot mitt on the back here. You can see it's got the word front printed into it, so assuming that that goes up, these will fit in there like that. Two of those. I think we need to do that first. And then we've got this spacer that goes in this end. I think that's easier to fit that afterwards. And then finally we've got this sort of hinge mechanism here, and we'll run a bolt through there. So I'll start putting some of that together. So there's one in. They're quite difficult to get in. You have to kind of just file around these parts until they start to mate together. Just take your time with them, because this part took 3 to 4 hours to print, so you don't want to be snapping off these little dovetail joints. So then next we'll need to put this threaded nut in here. And it just sits in there like that. It wants to be able to rotate reasonably freely, because that needs to turn a little bit. I don't think it has much movement in it, but it does move a little bit. It's important to put that piece in before you put the next side on. So I'll just pop this side on there now. So that's on there. Next we've got this spacer. We can just probably just get that in there. Probably should have gone in first, but it does flex a bit, so can I do it with one hand? Yep, there we go. So the space is in there. So we've now kind of got the whole frame assembled. I'm going to put this hinge on next. You probably should attach this to the forearm first and then attach it on. I'm just going to put it on for now so we can see the mechanism working. So just pop that bolt through there. This whole thing is quite a clever design, really. I was looking at this part earlier and wondering why it's hollow down in here. I thought maybe it was just to save plastic or something. But now I've got this threaded part in here. You can see how it works is when this part rotates with the servo. It's a little hard to do with one hand, but it kind of transforms the rotational movement of the servo into linear movement in the arm. So as that just screws in like a screw, it's actually coming out through here, and then it will fit in there. So it's kind of clever how the hole has been designed in this part here, so it can accept this screw when it screws in, just as clearance. I think it's quite clever, and I think the whole thing just tilts ever so slightly as it rotates in. I am fascinated to see it work, and I'm not quite sure how all the mechanics work, but I'm kind of getting the idea as I'm assembling it. It's starting to come together. So I need to take that out of there, and that needs to attach onto our other servo here. So I'll get that attached. So I've put 2 screws in just to see what the clearance is like. The screws are a little bit too long, but we do have clearance, so I don't need to cut them down. You might want to cut them down if you want it to look a bit neater, but I think that'll be okay. I drilled out the holes in the threaded piston to 3mm, and then the holes in the servo horn to 2.5mm. The holes don't perfectly line up, but if you try and put the 2 screws in kind of at the same time, you can get it to fit. I think once you've got two in, the other two would be easier. You do need to attach the horn to the servo first, which I haven't done yet. I just wanted to make sure that the screws are all going to fit okay. So I'll need to unscrew that now and put the screw in the servo horn. It comes with a little black screw that goes through the center. So I'll do that. Okay, so I've got it in there. I'll probably try and take it out again so I can show you. You kind of have to thread this in by hand. Just turn it and thread it in there. You can't really turn the whole mechanism because it needs to stay upright to fit in there. You kind of just got to turn this by hand. I think these wires have to be taped in place. I think what people do is they run them across the servo here and tape them to the top of the servo. I think they just need to be held tight so that they don't get trapped in here. There isn't much room there. There is clearance for the wires. They will be fine, but there isn't. You don't want them getting snagged, so I think the idea is tie them down or tape them down so they're not moving around. I'll have to try and tidy that up in there. So I guess the next thing is to attach this. That should just slot in that hole. There are two flat edges on this, so they have to line up with the two flat edges in there. It's pretty obvious. Looks as if there's supposed to be some nuts fitted inside here, 3mm nuts in here and in here, and then presumably a 3mm bolt through here and one in the other side that will go into those nuts. There is also two more fixing holes on the top here, and there's screw holes to line with them down here. I guess you could just put some self-tapping screws in there just to give it a little bit more security, so there'll be 4 screws holding it in total. It's probably going to be a bit fiddly, so I'll do that off camera. So the way I do these is just fit a nut and bolt through there temporarily. Normally the nut wouldn't sit that deep in to start with, and then I just heat them up a little bit with a heat gun. You need to be really careful because this plastic melts really quickly. You don't have to get it very hot. It really will melt and then you'll destroy your parts. Just give it a gentle heating and then very gently just tighten the screw up and it'll pull the nut into the hole. But like I said, you have to be really careful not to overheat it because you'll just melt it. So when you got it hot, just tighten up the screw, but do it really gently. You don't want to overdo it because the plastic will be really soft and the head of the screw will just sink in. It'll distort. Just go really gently with everything. So all we need to do now is let that cool down, and then we can take these bolts out and the nuts should remain in there. So I've pushed it on. There is a bit of play in it. I think the reason for that is it's supposed to have ball bearings inside there. You're probably supposed to fit ball bearings in there and grease to give that a lot more support. So I think that will need to be done before we put it under any serious load, but I think it will just be fine to get it just moving about a bit. I think I could just see my nut down in there, in this hole here as I tilt that, so I think everything's lining up. So I'll bolt that in. So I put 2 3mm bolts through here, one in the other side. They're fairly short bolts, I'm not sure, they're probably 20mm. I'll get a proper measurement at some point. But they look like they're still a bit too long because they look like they're going to hit the threaded pistons running through there. Just look down there in in that space there, and you can see the screw coming through, and I think that's going to touch the piston, so and they need to be about 5mm shorter. Let's see if I can find something to measure these. Okay, yeah, so the screws I used are 20mm. So I think what you want is something about probably about 16mm. And it looks like the screws I've got are probably 10 or 20, so typical. Haven't got anything the right length. Might just get away with that. I've taken the servo gun out and fitted those 2 screws down in there. I used number 4, 3/4 inch long. So whilst I got the servo out, I'm going to tape these wires down to stop them from getting snagged. I think people normally put them under the servo horn, but because I didn't file my screws down, my screws are sticking out and they would catch on these wires. I'm going to keep them clear of that as well. I think I'm just going to tape them down here. They just want to be kind of nice and tight down there. Okay, it doesn't look the best, but I've just put a couple of bits of tape there just to tape those wires down, stop them floating around. I'm going to try to show you how to put this in here. This might not be correct. This is the way I'm doing it. We need it to finish up kind of in this position with this slope piece at the top. So if you turn it upside down, you can put it in the thread, and you can get kind of 1/2 turn on it. Oh, I thought you could. Yeah, 1/2 turn on it, and then you can drop it down, and then you have to manually wind it the rest of the way. Hopefully that explains that. So that's back in there now. I'm not totally happy with these cables. I think they're going to chafe on there. Let me try and get the camera down there. They're actually touching the side, so as they move backwards and forwards, it's going to rub on those cables. So we need a better solution than that. So it's basically there. I need to repair this pot and put that back in there. And I think we could power it up. The forearm would attach on here to see the whole thing work, and we really need to attach the forearm. That's going to be quite cumbersome because it's going to be kind of heavy and sticking out there. So I might just see if I can power things up. Maybe just get this servo running for a start. We could just put some power on this. We'll see that screwing in and out, but we won't really see the elbow joint working until we attach the forearm. So one last thing we need to do before we can connect this up electrically is to just connect up this pot here. I was looking at how long to leave the cable, and I want to leave enough slack on this so that even when the servo is fully pushed up against this block, which I'm not sure if you ever do get that far, but if it did get that far, I want to make sure there's enough cable in here to not be too tight. Don't want anything tugging on the wires. So rather than leaving it really short like this, I want to make sure the servo can move. We'll have enough cable for it to come that far in. So that should be fine. If I remember rightly, we need to connect up the red to the red, the white to the yellow, and the black to the green. I'm not sure if we have to reverse any of these cables to get the correct direction of movement. So I'm just going to connect them up how they were originally and see what happens. If it appears to be backwards, then we might have to swap a couple of the wires over. I believe we leave the center one where it is and we swap the red and the green. Okay, so that's soldered on there now. That's not the best soldering I've ever seen, but it should be okay. So I've been thinking about this, and I'm thinking if I'm not careful I could end up breaking something here. When we power up this servo, it's either going to start winding inwards or start winding outwards. And remember, there's no mechanical stop in there now because we've removed it. And it'll only stop moving once this potentiometer has reached the programmed position. So I'm going to have to quickly move that and figure out where the position is to make this stop. So I think what I'm going to do is program the Arduino to command them to position 90, which I think is the center. Although theoretically there is no center now that we've removed the physical stops. But it should be the center of the potentiometer. And if I start with the potentiometer roughly in its center position, we shouldn't be too far off where we need to be. I'm less concerned about this one. I think we played around with this one before, and I think that's going to be fine. And there's nothing physical for this to hit. It could just continue rotating forever. It's not going to hit anything or break anything. But this is either going to go flying inwards or flying outwards, and it's not actually connected to this pot because we don't have the forearm connected, so it's not going to turn it automatically. We're going to have to turn this manually. So I need to be a little bit careful, and maybe in an emergency just unplug the cable if things look like they're not going right. So I'm going to reprogram the Arduino and then we'll come back and power it up. So I've powered it up. It's very easy to break something here. If I just turn this very slowly, you should just be able to see this mechanism move in here. That's moving outwards. I'm turning clockwise. If I turn anti-clockwise, we move inwards. Clockwise brings us out, and anti-clockwise moves us in. Seems to be a couple of points of maximum. This does seem to screw all the way into the block, but coming outwards it hits this mounting bracket down here. I thought there would be more tilt on this. It doesn't seem to want to tilt, and I think it's because it's hitting inside here somewhere, so it's difficult to see. Now it could be that my screws here, this screw here, you can just see down there, could be catching on that. I probably need to use shorter screws in there. That might be stopping the tilt mechanism, and then if it could tilt it might lift up and clear this bracket. So I think that's the problem. The screws in there are too long. These screws in here are too long. But I figured out that turning it clockwise moves it outwards, and anti-clockwise moves it inwards. So it kind of moves in the direction of the top of this gear. So that the top of the gear moving that way is moving the piston that direction, and the top of the gear moving in this direction is moving the piston outwards. I'm mainly just saying this for my own reference so I know what's happening. I can watch these videos back and see what happens. I need to figure out if that's correct or if it's back to front. So if we think about that, this gear is going to be moving in the opposite direction So tilting upwards is going to move this gear in that direction. Oh, I'm really not sure, it's really confusing me. I'm going to have to think about that. I've connected up the rotation servo now. It's pretty difficult to hold everything, but if I turn this pot, you can just see it is rotating the arm. Turn it the other way. Rotates back. Okay, so I think I'll end this video here. I'm fairly happy with the progress we made on the Bicep. There are a few things I need to come back and revisit on this. Specifically, we need to get some ball bearings to fit in here to just tighten this up a little bit. These screws are a little bit too long, so we need to shorten those. We'll get some shorter screws for those. And we need to sort out these cables in here. Route those a little bit better so they don't catch along the edge. I didn't get around to fitting these reinforcing brackets on the side. They're called reinforcing brackets. They probably do add a little bit of strength, but they're mainly there to attach the coverings, which is with the last thing I need to complete. There are coverings that cover this whole Bicep over. So we will come back and revisit this at some stage in the future. I think in the next video I'm going to turn my attention back to the torso. I've got most of the upper torso built, but there are a few pieces missing off the bottom of it, so I think I'll just come back to that and get that a little bit more complete. So thanks for watching. If you liked the video, please hit the like button, and if you haven't done so already, subscribe to the channel, and hopefully we'll see you next time. Thank you.